Assalamualaikum and good day students. Welcome to part 2 of topic 7, which is data analysis. So for this part 2, we'll be looking at the characteristic of distribution in terms of what is average, dispersion, skewness of data, and courtesies of data. So basically this is the basic normal distribution data, or what we call as a bell curve. Average, also known as mean analysis. Average means mean analysis. It's a typical size of a score value that represent of that distribution of score. So however, you have to remember in statistics we have two, right? One is a population and one is sampling. So in sampling, it is called it is represented with the mean symbol, and in population it is represented with mu sample. Okay, so this is what we call as a mean. Okay, so it will be used in a different setting, sampling and population. The mean of sample is designed by the symbol of X bar, which is this one, and may not always be the best measure of a central tendency if the data is skewed. So what is that data skewed? We'll be talking about that in a short while. So for example, average income is often misleading since those few individuals with extreme high incomes may raise the overall average, which means when we said now we have the B40, M20 and T20 class and of average income in Malaysia. So if you want to look at the students in the class with family in average income of B20, T20 and so on, so we want to make average of that income in the students in the class. So we can get the average by looking at the the frequency and total up and get the mean score for that. But it sometimes can be misleading because there are a few extremely high income that will influence the mean data. So as I mentioned, in sample, mean will be represented with this symbol, and in population, mean is known as mu. So when we talk about mean, median and mode, okay, normally it will be in a typical bell curve. Why it is called bell curve? Because it resembles the bell symbol. Okay, so so dispersion indicate how spread out the data around the median. So we know in the middle here is the median. Okay, so dispersion is looking at how spread out the data. Okay, this is what we call as spread from the median. Okay, so to measure the dispersion, we have to look at whether the data is skewed or towards left or right, or it's a perfect bell curve. Okay, for example here, this is what we call as a bell curve or a normal curve, and in the central line here is what we call as a mean. Okay, this is a mean. So some data will fall below the mean average, or some might fall more than mean average, and most of the data could be on the central of the mean. So which means this is how we are going to describe our data. So another example that I can give you is that presume that this line here is the exam marks. Okay, exam score in the class. So of course in the exam score there will be an average. Of course, some students will score lower than the average marks, and some students will score higher than the average marks, but most of the students will score in very near to the average marks. So this exam score line here also can be replaced with the weight, height of a person. It could be a level of blood pressure perhaps, or it could be also a level of sugar and so on. So the lines is actually the collection of the marks or weight or height of level of blood pressure of the particular respondent that we observe. So now that you know what is average and distribution, and also you are introduced with the term bell curve or a normal curve. So what is skewness? Skewness is the lopsidedness or asymmetry of the distribution. Normally where a bell shape, this is a bell shape distribution of data, which means that you have your mean in the middle, and also you have and normally for a normal distribution the shape will be symmetrical, which means left side and right side is the same. So this is the example of the skew, and this is what we call as a positive skew, where the mean is more than the mode, and it has a long tail on the right. Okay, so this is what we call as a right skew. And the second one is negative skewed, which means your mean, this is a mean, is less than your mode. The mode is here. Okay, so and where the long tail is gearing towards the left, or in other words, this is what we call as a left skew. And skewness and thickness of the data is very important because it will show you how your data is being distributed. And you have to remember this. Okay, you have your normal distribution data where you're going to have this bell shape. So where your bell shape, the mean and the median is equal. Say this is 12, for example. So the mean is 12, the median is also 12. But in the case of this, positive skew and negative skew, it will be different. It will be the same. Okay? So the last one will be the kurtosis. Okay, the kurtosis is a measure of a thickness of your bell curve and of the probability distribution and the real value random variables, although some resources are insistent that heavy tails are not thickness. Okay, what is thickness? So this is your bell curve. Okay, just now. And this is what we call as thickness. Okay, and so higher kurtosis means more variance of the result, and as opposed to the frequent modestly sized deviation. Okay, this is what we call as a flat kurtosis, which means that your data is still in a normal distribution but very flat curve, and this is what we call as a normal distribution with a normal kurtosis, and the green one is what we call as the thin kurtosis, which means that if you look at this, the mean, the median is still the same, but what makes it different is the data is being distributed quite flat compared to the normal bell curve. Okay, this is the example of curtices, which means you still have your median and mean in the central, um, and then however the distribution of data, that is different. Okay, so in other words, the smaller the standard deviation score also determine the bigness or the curtices level. So the lower standard deviation, there will be a very thin curtices, but the higher standard deviation means you're going to have a very flat curtices. So which means it's something to do with your data distribution, and you have to look at it, and the normal curtices will be at 3, and if you have more than 3 to infinity, this is what we call as a very thin curtices. But if you have less than 3, I mean the minimum figure for the flat curtices will be 1. Okay, so and basically you can have a manual calculation using your formula, a calculation using calculator, or you can use Excel. But now we have a software called SPSS that will help you to analyze your data. Of course, when you are using software, it's very important for you to get yourself familiar with the software, as well as be able to interpret the data correctly. So it will help us to ease the process and shorten the time in producing the data. But bear in mind, the researcher need to be able to interpret the data carefully and correctly in order to get a good result for your data analysis. I think that's all for this week on the data analysis. We'll do some exercises, calculation in the Google Meet class later. And till then, I know data analysis could be very complicated, slightly complicated for those who just involved in the research, as well as beginners in this research area. But practice always make perfect, and please read a lot, and some YouTube videos can help you also in understand about this data analysis for your research. Till then, Assalamu alaikum and have a great day, everyone.